Okay, so first let's answer the question, what is JavaScript? Like, this course is about JavaScript, we all know that. We also know that we want to learn JavaScript, but what is the definition of JavaScript? What exactly is the JavaScript programming language? Well, JavaScript, or JS for short, is a high-level, lightweight, interpreted or JIT compiled, multi-paradigm programming language supporting object-oriented programming, imperative and declarative styles that features dynamic weak typing, first-class functions, and prototype-based inheritance. Now, these are the main characteristics of JavaScript, and you might not understand what all of this means right now. Don't worry, as we go through this course, we will gradually start to understand what all of this means. But for now, just know that JavaScript, or JS, is a programming language that is mostly used on the web to add dynamic behavior to websites and web applications. Now, before we actually dive into JavaScript specifically, let's take a step back and talk about how the web works. Now, we all use the web, right? The internet is a core part of our digital lives, and if you're watching this video, chances are that you use the internet as well. Now, in the internet, we do a lot of things. We browse websites, we check email, we get a lot of work done, and we read news and articles, amongst a lot of other things. But how does this web actually work? How do the websites work behind the scenes? So on a fundamental level, how does the internet work? Well, internet means interconnected networks, right? Which means the internet is a mesh of networks which are all connected to one another. That's why they're called interconnected networks, or the internet. Now, in order to understand how internet works in real life, let's take a look at a very simple example of a network or a connection. Let's say that we have two computers, computer 1 and computer 2. Now, what if we want to connect these two computers? Say we want to connect these two computers together so that we can transfer data between them. We want to transfer files and other data in between these two computers. Well, one way of doing that would be using a good old Ethernet cable. So if we have an Ethernet cable, we can use that cable to connect these two computers together. And then when computer A and computer B are connected using that Ethernet cable, we can transfer data between them using that cable. So we can send files from computer A to computer B and vice versa. So in this case, using that Ethernet cable, we have established a connection between these two computers. We can call this a very simple network. In fact, it's the simplest a network can ever get, because it has only two nodes, or two parties, two computers connected to one another, and that is a very simple network. Now, on a fundamental level, the internet works in a very similar way. On the internet, instead of just two computers, we have billions and billions of devices that are all connected to the internet, and that creates a very big network connecting all the billions of devices from around the world, and that is what we call internet. Now, in our example, we had two computers which we connected using a simple Ethernet cable. But in the real world, all the devices on the internet connect in different ways. Some of them connect using a cable, for example by using a fiber connection, or a dial-up connection, or maybe a wireless connection, such as Wi-Fi, or maybe carrier-based cellular data. We have submarine cables which connect the different continents and different countries together on the internet. Another thing to note that, in our example, we had two computers, and those two were connected using an Ethernet cable. But in the real life, on the internet, we don't just have computers. These days, we have a lot of different devices. We have, for example, computers, including laptops, desktops, convertibles. We also have mobile devices, such as smartphones and tablets. We also have wearables, smart speakers, amongst a lot of other things. So these days, we have a lot of electronic devices that can connect to the internet. And the internet is made up of all these devices connected in one way or another. Now, when we have two computers connected using a simple Ethernet cable, because we only have two computers, it's really easy to identify them and communicate between these two computers. However, on the real internet, we have billions of devices from all around the world. So how do we recognize a specific device? That's why each device that connects to the internet needs a unique ID, right? We need some way to identify that specific device on the billions of devices that are connected to the internet. And we do that using an IP address. An IP, or an Internet Protocol address, is a unique ID that is given to each device that connects to the internet. And that unique ID can be used to refer to that specific device on this pool of billions of devices that are connected to the internet. Now, amongst all the devices that are connected to the internet, a lot of them are consumer devices, which means they're used by the general public. So when we, for example, use the internet from our computers or our smartphones, we are connecting to the internet through those devices. And using that computer or smartphone that is connected to the internet, we might browse the web, check email, or maybe read some news and articles. And all of these things we're doing from our computers and smartphones. These computers and smartphones that we use to access the internet are known as consumer devices or user devices. However, there is another type of device that is connected to the internet as well, and this type of device is known as a server. Now, servers are just like ordinary computers, although they are a lot powerful, but fundamentally they're just a computer. But the difference is that these computers stay connected to the internet almost 24/7. So while a normal user might connect to the internet, browse for a few minutes and take some emails and stuff like that, and then they might disconnect from the internet. And when they do, their device is offline. They're not connected to the internet anymore, and their device is not available on the internet as well. However, server computers have a very high uptime, which means they actually run and stay connected to the internet almost 24/7. And that is because these server computers are usually serving an important resource. For example, a website. So if you have a website and you want to make that website available on the internet so other people can access it, you need to put that website and all the files related to that website on a server computer. And that server computer will be online and it will stay connected to the internet almost 24/7, which means it'll be available whenever someone on the internet asks for that website. And this is how the web works. When you have a device which is operated by a user and that is connected to the internet, and you have your server computer which serves and hosts your website, and that is also connected to the same internet, then the user can request access to the website through the internet using a web browser, and the server will receive that request and respond to it with the correct website files. And those website files will travel back through the internet to the user's device, and it will be loaded, and the user will have that website available on their device. So if we try to visualize this whole diagram, this is how it probably looks. So first we have a device. By device here we mean the user device. So it can be a smartphone, it can be a computer, it can be a tablet, laptop, desktop, or a wearable, or a smart speaker, it doesn't matter. It can be any electronic device that can connect to the internet. And this device is usually operated by a normal user, so a normal person like me or you. Now after the user has connected to the internet, let's say that that user wants to visit a website. Let's say the website example.com. So if we have a website example.com and the user wants to visit that website, what does she do? In most cases, the user will usually open up a web browser. So a web browser is a software that is available on the user's device. Now as we know, there are a lot of popular web browsers, such as Google Chrome, Mozilla Firefox, Microsoft Edge, Apple Safari, amongst a lot of others. So let's say that a user has one of these installed on that device and she uses that to browse the internet. So she opens up the browser application and on the URL box or the search box, she types in example.com and presses enter. And the moment she presses enter, the browser actually sends a request through the internet to the server that actually hosts the website. And this request is what we call an HTTP request, or a Hypertext Transfer Protocol request. Now internally, all the devices on the internet are recognized by a unique IP address. However, normal users usually access websites by domain names. For example, the user might type in example.com. Now in this case, the browser will actually have to send a request to a DNS server first. And that DNS server will convert the domain name into a related IP address. So the browser will basically ask a DNS server, hey, I need the IP address of the server that hosts this example.com website. And the DNS server will search through its database of all the different domain names and the related IP addresses, and when it finds the example.com domain name, it'll also find the associated IP address of the server that hosts the website. So in this case, we have a server which has an IP address, and that server hosts the example.com website. So the DNS server will respond back with the IP address of the domain name. So a DNS server basically takes a domain name and translates it into an IP address. Now once the browser has the IP address, the browser can send an HTTP request to that specific IP address. So basically, through the internet, the browser sends a request to the specific server that hosts the example.com website, telling that server that, hey, I want this example.com website on my device. So it sends an HTTP request to the specific server. And here we have the server. Now the server, as we just said, is like any other computer, although it's a very powerful computer and it stays online almost 24/7. And this server's storage has all the files of the example.com website. Furthermore, this server is open to HTTP requests. Basically, it's ready to serve the example.com website's files. So when it receives an HTTP request from the user's device, it does some processing on its own. Depending on how complex the website or the web application is, we might have the server first, which is a server software. We also might have a server-side scripting language, which defines the backend of the website. And we might have databases as well, which permanently stores data on the server. So after going through all these processes, The server finally comes up with all the files for the example.com website, and those files might contain the HTML, CSS, and JavaScript files of the example.com website. So when it's done processing the HTTP request, it responds with an HTTP response, and this response contains all the files of the example.com website, and all these files travel through the internet to the user's device, and the browser takes all those files and loads them up inside the user's device, and thus now the user can see the example.com website. This is how the web actually works. You have a device with a browser application or something like that which is able to send HTTP requests, and you have servers ready to serve those HTTP requests, and that server actually contains the website or the web application, and the server's job is to process the HTTP requests, figure out what to do in response, and send that response back to the device that sent the original request. So in this case, the user's device basically asks the server, hey, I want this example.com website. And the server says, well, okay, then here's the website files. And this sends the website files, and the browser inside the user's device takes those files, loads them up, and thus the user can now see the example.com website. This is how websites and web applications actually work. Now, if the website is a static website, then the whole process is actually very simple. Because then on the server, you just have the static website files, including HTML, CSS, and maybe JavaScript. And all these files will be stored on the server. And when a user's device from the internet requests those files, the server will basically just serve those files up, and the device browser will load them up, and the user will have access to that website. However, it gets a little bit more complex with dynamic web applications. In that case, you'd usually have some server software on the server computer. And before sending a response, the server will most likely need to do some processing on its own, and that is done using server-side scripting language. And these server-side scripting languages often come with frameworks, and sometimes these frameworks actually bind the server and the server-side scripting language together in one big application. You also might have databases, and these databases can be SQL databases or no SQL databases, and these databases can be used to store data permanently on the server. So, to illustrate how this works, let's say that the example.com website actually has a users area, where a user with an account can actually log in with the email and password. So first a user visits the example.com website, and then on the login page, she inputs her email and password and presses the login button. Now usually the HTTP request that is used to communicate between the server and the device is an HTTP GET request. But in these cases, when we need to send some data from the device to the server, for example in this case, we need to send the email and password from the user's device to the server, so the server can actually evaluate whether the email and password is valid or not. In those cases, you'll usually use an HTTP POST request. Using an HTTP POST request, you can actually send some data along with the request. So in this case, when the user inputs her email and password and presses the login button, the browser sends an HTTP POST request. And inside the POST request body, it also sends the email and the password that the user has entered. And this POST request is sent to the server. So when the server receives this POST request, it also receives the email and password the user has entered on her device. And this is where server-side scripting comes into play. Because here the server-side script or the backend web application actually takes the email and password from the POST request, and then it searches its database. And in its database, it has a list of all the emails and passwords of all the users of that website. So when the server receives the HTTP POST request along with the email and password, then the server-side script or the backend of the web application actually searches the database for that specific email and password. And if it does find a match, it responds with an HTTP request allowing the user to access the user's profile or the dashboard. But if it can't find the email and password and those two doesn't match, then the server responds, sorry, that email and password is not valid, so try again. And that's how we have different types of HTTP requests for different types of operation. Usually we use an HTTP GET request. However, if we want to send some data, we would usually use an HTTP POST request. If you want to update some data on the server, often an HTTP patch or put request will be used. And if you want to delete some data from the server, often an HTTP delete request will be used. So we have different types of HTTP requests for different types of operations. And the user's device and the server computer communicates with one another using these HTTP request and response protocols. And this is how the web works. Basically, on the web and on the internet, we have billions of devices connected to the same network from all around the world in one way or another, either actively or passively. And some of these devices are user devices, which normal people use to browse the web. Others are server computers, and these servers are actually powerful computers which stay connected to the internet almost 24/7. And these servers are almost always online to serve some important resource, for example, a website or a web application. And the user's device and the server communicates with one another, sending data back and forth using HTTP requests and responses. And through this protocol, data is sent back and forth between these two devices. Now these days, oftentimes we have more modern single-page web applications. And these web applications actually communicate with the server through AJAX requests using a data type known as JSON. Now AJAX means asynchronous JavaScript and XML. And using AJAX, the device can communicate with the server asynchronously using HTTP requests. And in these cases, a syntax known as JSON or JavaScript object notation is used to send data back and forth between the device and the server. And when the browser receives some JSON data, it parses and interprets that data and loads it up inside the browser in the web application. Now all the HTML, CSS, and JavaScript that is loaded inside the user's device and browser is known as client-side code. And all the code that stays on the server is known as server-side code. And that's why programming web applications on the server is known as server-side scripting. And programming web applications for the user's device is known as client-side scripting. That's why the application loaded inside the browser of a user's device is known as client-side, and the server is known as server-side. And JavaScript is actually executed inside the user's browser, inside the web application that is loaded. And that is how the web works in a nutshell.